Hello, scholars. Welcome to day one of our distance learning. I want to start by reviewing this section. It's 0-7. Remember, your textbook has a chapter 0 before chapter 1. That's where I am. I want to make sure that we cover all the important ideas about probability, so we can combine that with the statistics part of our study that's coming up, so that we can use what we know about probability and combine it with what we know about statistics to make predictions about how likely something is to happen based on data that we might have. So we talked a little bit about permutations and combinations already. I want to make sure we understand some other important ideas about probability. The first is this idea of an experiment and its sample space. An experiment is just something that's going to happen where you don't know what the outcome is. If you're going to flip a coin, the sample space is heads or tails. You might write out a sample space of heads or tails. Whether you write out the word or not, that's not a big deal. We just want to give an idea of what the possible outcomes are. If you asked to give the sample space for rolling a die, you might give 1, 2, 3, 4, 5, 6. If you asked to give the sample space for the experiment of rolling a die and flipping a coin at the same time, you would have to have a more complicated list. So you could have a flip of heads and roll a 1, you could flip a heads and roll a 2, flip heads and roll 3. And you could write out that list. There would be 12 items in that list because there are 2 different ways to flip a coin and 6 different ways to roll a die. So 2 times 6 different possible outcomes. That's from the fundamental counting principle that we did talk about a little bit before. We have an introduction here too about independent and dependent events. You can imagine that experiment of flipping a coin and rolling a die. When you flip the coin, there isn't any way for that outcome to influence what happens when you roll the die. So those 2 events we would call independent. When one part of the experiment does not affect the outcome of the other part of the experiment. Think of another situation though. If you're going to pick a card from a deck of cards, you're going to pick a card and then later you're going to pick a second card. If you don't put the first card back, then the fact that that first card is gone does affect the possible outcomes for this second drawing. So those events we would say are dependent. So independent events, the 2 or more parts do not affect each other. Dependent events, whatever happens in the first event does affect the possibilities for the second event. So a quick reminder here about permutations. If you have n things and you're going to arrange them, how many different ways are there to arrange them? Well, an arrangement implies that the order matters, and we said that there are then n factorial ways to arrange n items. If you have n things to choose from and you're only going to arrange r of them, we said that there are n permute r ways. That's n factorial divided by n minus r. For combinations, we said the order doesn't matter. If you have 10 students, you're going to pick 3 to go on a trip, and those 3 don't have any special precedence over each other. Then we called that a combination, and said that there are n choose r ways to do that. Or that's, I'm going to write it big so you can see it in case you can't see that's n factorial over n minus r factorial times r factorial. The really big idea that I want to make sure we touch on in this chapter, this section, is kind of stuff it's hiding inside here and it's hiding in part B. So I want to make sure we understand part A. If you have a 7-digit code, you're going to use the digits 0 through 9 with no repeats. Could you figure out how many different codes are possible? Well, we have 0 through 9 is 10 digits, and we're going to choose 7 of them, and the order matters. So that's 10 permute 7, which we could figure out. You could do that on your calculator, or you could work it all out. So 604,800 ways to make that code. Watch question B. If you randomly make one of those codes, what's the probability that the first 3 digits are odd? Well, here's the big idea. That probability probability in general. It's going to be the number of ways you could make a code that it passes the test that has the first 3 digits that are odd, divided by that total number of possible codes that we just figured out in the line before. So could you figure out how many ways could you make a 3 odd digit code? We're going to divide that by the 604,800 possibilities. So notice here, for this problem, we're going to use that fundamental counting principle. It doesn't matter what the last 4 digits are. We just need the first 3 digits to be odd. So the way to choose, see that my blue line is right on top of what we need. Let's squeeze this out. All right, so how many odd digits are there? 1, 3, 5, 7, 9. There are 5 odd digits, and I need to pick 3 of them. So that's, there we go. That's the 5 permute 3. I have 4 digits that I'm going to choose, right? And there are 7 digits left to choose from, so that's 7 permute 4. And when I have those possibilities for the first 3 digits, the possibilities for the last 4 digits, I need to multiply those possibilities together. That's the fundamental counting principle. And then that product, that's the number of ways there are to choose a code that has 3 odd digits to start. It's going to get divided by the total number of possible ways to make a code, which is the 10 permute 7, which we figured out from the slide before, from the part A before. All right, those are the big ideas I want to review in 0-7 from your textbook. If you could do numbers 25, 27, and 31. The first 2 problems are about a gumball machine that just is going to spit out 3 gumballs. So I'll just give you a little hint that here the order doesn't matter, because when 3 gumballs come out and you pick them up from the thing, it's not like you're going to know which gumball came first. So consider using combinations for that. Otherwise, you'll find it's pretty similar to this example we just did. If you have questions or problems, please don't hesitate. Please don't hesitate to contact me. Try to stay in touch with your friends who might not have access to the videos. My idea, my thinking as I make this is that it's going to go up on touchcast.com/Mrs. Hicks. If something goes wrong with that posting, I'll have a YouTube link that I'll put in the up in Schoology. Share it with your friends. None of this has to be, hidden or hard to find. Let's help each other and make sure everybody stays safe and healthy, okay? Miss you guys. Bye.